webinar of 2021. I think last year we started the webinar series and it has been pretty successful. We are proud that we've created this little global community of people having a shared interest in the intersection of economics, nice exciting data sets and novel methods. And so this is the first webinar this year, and we are pretty excited to have the amazing Peter Hull taking the lead and that he agreed to present. Peter Hull is from the University of Chicago, and he's basically an applied microeconomist. He works, I would say, develops novel methods and applies them to questions related to labor economics, but also healthcare and education. And today he talks about measuring racial discrimination in bail decisions. Just regarding the rules of the webinar, as usual, you can post questions in the chat or raise your hand. And also Peter said that there are a few natural breaks in the presentation where you can then ask questions in the forum. And the last 15 minutes, depending on how it goes, we will give Peter to finish up the presentation. Otherwise, that's it. Peter, the floor is yours.
Great. Well, thanks very much for that kind introduction, and thank you for having me here today. I'm very excited to present this work. It's joint with David Arnold at UCSD and Will Doby at Harvard Kennedy. Let me add one more addendum to the rules here, I guess. If you're comfortable turning on your video, I very much welcome that. It's a little easier to present to faces than to a blank screen, but of course, no worries either way. But it'd be great to see everybody. So let me start by motivating this work. In the US, this motivation is very straightforward. Depending on your background, it may be less straightforward. But in the US, especially in recent years, it's been a large concern that sort of across the criminal justice system, we see large and systematic disparities along racial lines, disparities in the treatment of individuals who might otherwise look very similar. So, for example, from police search to criminal charges to detention, conviction, and incarceration, you tend to see, say, white individuals and Black individuals receiving systematically different treatment. Now, many people take this as evidence of racial bias and some form of racial animus or discrimination by the hands of the actors in the system, such as police officers or prosecutors or judges. But the sort of starting point for this paper is that sort of connection is not necessarily the right one or the only one. And there's other possible explanations for these kinds of racial disparities in the criminal justice system. So I'm going to give you two alternative stories here. So it could be that we see racial disparities not because of racial bias, but because of agents acting on legally relevant unobserved differences in the two races. So it could be that, for example, Black individuals are detained before trial at a higher rate than white individuals because Black individuals are, for whatever reason, systematically more likely to engage in some form of criminal misconduct if they were not detained. So that's an example of what I'm going to call omitted variables or omitted variables bias in this setting. The fact that we don't observe sort of everything about the person, and so there may just be sort of residual unobservables driving the racial disparities that we see. So that's one possibility. A second possibility is that there is discrimination, but it's not driven by sort of racial animus or other forms of bias. It's instead just sort of classic, accurate statistical discrimination. So it could be that Black individuals do tend to be riskier than white individuals, and judges or prosecutors take that into account. They form a sort of accurate prediction of an individual's risk using some information set. and they act accordingly. And in doing so, create racial disparities, but not because of any racial preferences, just because of sort of the statistical prediction problem that exists. And so, these different explanations are kind of hard to tease apart empirically. They sort of manifest similarly in the data. Obviously, we can only control for the observables that we see in the data. So this potential for omitted variables bias, or OVB, looms pretty large in this setting. And while the recent literature has developed some methods to try and get at racial bias, it's very difficult actually to use those methods to understand statistical discrimination. And so there's for many reasons sort of a deficiency in the types of empirical tools we have to disentangle these three potential explanations for racial disparities. And so that's really where this paper is, that's the gap this paper is trying to fill. And so what we're going to do in this paper is develop and apply new quasi-experimental methods to disentangle these three sort of alternative stories. The first agenda for us is to really, separate out the OVB problem and understand how much of the racial disparities are driven by relevant differences in individual risk versus, unexplained differences. And then we're going to try and sort of understand what's left over, the residual differences, once we effectively control for differences in risk, try and understand whether that's coming from some form of racial bias or some form of statistical discrimination. Now, specifically, we're going to, this is a methodological piece in the sense that we're going to be developing these new tools, but then we're going to show how they play out in a very particular setting, which I'll talk about next. And that's going to be pretrial decisions or bail decisions in New York City. And to get at this, we're going to leverage quasi-experimental variation in bail judge assignment. So let me now talk a bit about this setting, just to make sure we're all on the same page about, sort of some of the concrete items here. And then we'll talk about the methods. So in the US, I'm actually not sure how it works in Australia, but in the United States, after somebody is arrested and arraigned, they have conditions for their release set at a bail hearing or pretrial hearing. During this hearing, a variety of information about the defendant and the case is presented to a judge, and the judge makes some decision about whether to release somebody before the trial or to detain them in jail, effectively. And there's a variety of decisions that the judge can make, but to first order, the judge is making that sort of binary release or detain decision. They might release somebody, quote, on recognizance, or just sort of set them free without any conditions, or they might set some form of conditions, typically monetary conditions, which the defendant has to pay in order to be released. Now, these decisions are very high stakes for defendants. That's been actually the subject of recent research in this area, which has used the similar sorts of variation that we're going to be using today to just study the effects of being denied bail or being detained before trial. Those effects have found to be quite large, both in terms of conviction rates ultimately and economic outcomes like employment status. So this is a very important decision, which is one thing that's sort of nice for developing our methods in this setting. Another thing that's nice is that the judges have a very well-defined objective when making these decisions. So in deciding who is released or detained before trial, the judge is really instructed to think about what we call pretrial misconduct. So that can either be a failure to appear, or FTA, where somebody is released before trial and then fails to sort of come back for their trial. So that's one bad outcome that the judge is trying to avoid. The other is that a defendant will go out before trial and commit some further crime. And so, these are outcomes that we can at least partially measure, and we know that the judge is sort of instructed to care about them. And so what we're going to use this outcome to define a notion of discrimination. And that notion is going to be whether a judge releases white or black defendants at different rates, conditional on their true potential for pretrial misconduct. So what we're going to argue is that a reasonable notion of discrimination in this setting is that white defendants are released at a higher rate than Black defendants, holding fixed sort of their true risk. And that's going to be something I'll formalize on the next slide. The third sort of useful fact for us about this setting is that we do see large release rate disparities in most systems, including in New York City, where we'll study this today. So in New York City, just to give you some sense of magnitude, there's overall about a 7 percentage point release rate disparity between white and Black individuals. And that's sort of unconditional. That's just, if you look across white and Black defendants, white defendants are released at a higher rate. If we add a bunch of demographic and sort of case characteristic controls to that comparison, it shrinks a little bit to 5 percentage points, but it's still not zero. And it's still, you know, roughly in the order of 8 to 10% of the average release rate in this setting. So it's a pretty sizable disparity, both in absolute and relative terms. And so the first question that we're going to try and answer here is how much of this gap is warranted in terms of the legal objective I just mentioned. So how much of this disparity is driven from the fact that white and Black individuals sort of have different potential for pretrial misconduct, and how much of it sort of remains once we account for any of those such differences. I see there's some questions in the chat, so let me pause there and see if I can answer those. So Sasha asks, these are bail bonds, right? Yes. So these are bonds in the sense that a bail amount is set and the defendant has to pay some fraction of that amount, which is then returned to them if they successfully come back to trial. I don't want to get too hung up on the monetary amount, which for a reason which will become clear in a little bit. The main margin of sort of decision-making in this setting is really not about the monetary amount. It's whether the defendant is released on recognizance versus detained by some other means. So the vast majority of release in this setting is going to be without any conditions, and the vast majority of people who are set some monetary conditions end up not paying them or not being able to pay them, and so are detained. But happy to return to that when we get to the point where I can show you some data. And then there's another question by Pushkar. Can judges take into account previous criminal history in the pretrial? I would assume so. They can. Yep, they can. I'm going to argue that the way we should think about that is judges can use information to try and predict an individual's potential for pretrial misconduct, but that's really going to be the objective that judges are going to care about. So other information is going to be useful to the extent that it is predictive of, you know, potential outcomes from the release decision or not. And so that's what I'm going to argue is the objective, at least in most jurisdictions. But we can talk more about that decision as well as we get to the data.
Peter, also just a quick question: are lawyers involved at this stage as well?
Yeah. So you know, prosecutors will write briefs, and so yeah, there are lawyers involved in this stage. I'm going to focus on the judge's decision here, sort of thinking about anything that goes into that judge's decision. I'm going to sort of map it to the judge. So that's actually an important thing to think about here when we're thinking about, you know, interpreting these estimates. The decisions of a judge might depend on what is presented to them, which could include, you know, other actors in the legal system. It's a good question. Okay, let me push on. Is the bail judge and the trial judge the same one? No, they're not, actually. So that is a good clarifying question here. So the bail judge is typically independently assigned from the judge who's assigned a trial, and the bail judge is not mandated to pay any attention to the potential guilt of a defendant. They're not they're sort of explicitly told not to do that, in fact. Their only goal really is to control this pretrial misconduct rate and not think about necessarily the merits of the case, except to the extent that they inform the pretrial misconduct potential. Okay, let me push on, and if there are other contextual questions that come up, let's definitely get back to them when we start talking about the data. But let me instead now formalize that notion of discrimination that I sort of gave in words on the previous slide. And let me do that with some very simple potential outcome notation. And so for each defendant I want you to imagine that we have this variable yi star, which denotes an individual's potential for pretrial misconduct if they were released before trial. So this is a latent variable. It says if y star equals 1, that individual I would engage in pretrial misconduct if released. And if y star equals 0, it says that they wouldn't engage in pretrial misconduct. So we're going to start with a very simple binary y star, but we can talk later about how we can extend this approach to non-binary outcomes. Let me also define an indicator for whether an individual would be released before trial if they were assigned to a given judge J. So dij is going to be 1 if judge J would set somebody free, and 0 if they would detain them. And finally, let me write race as R here. So then the object that the parameter of interest for us, the thing that I'm going to in a second hopefully convince you is a reasonable measure of discrimination in this setting, is this object delta J. And let me break down what this object is by focusing on the colors here on this slide. So in blue, what I'm showing you is the difference in release rates for judge J of white individuals versus black individuals, holding fixed their potential outcome, holding fixed their potential for pretrial misconduct yi star. So that's a conditional on y star comparison, and then in red, sort of I'm just averaging over the distribution of y star to translate that into just a single index. So what this says is, on average, if delta J were positive, it would say that on average, judges release white defendants at a higher rate than black defendants, conditional on their potential for pretrial misconduct, or that white defendants with identical sort of potential for pretrial misconduct versus black defendants tend to be favored in the sense of having higher release rates. So I'm going to argue in the next slide that this is a useful parameter to estimate. One thing I want to emphasize here is that it's judge level, so it's judge specific, and that's going to allow us to say things not only about sort of the average value of this, what I'll call discrimination, but also the distribution of it across judges. Now, of course, if we observed pretrial misconduct potential, we could just compute this thing in the sample and estimate it directly. And so the key measurement challenge, the key sort of omitted variables bias challenge in this setting is that the thing we want to condition on, the thing we want to control for yi star is unobserved. For some defendants, it's unobserved in particular for defendants who are detained before trial. So we can't just condition on it directly. We can see it for the people who are released. We can see whether they go on to commit further crimes or fail to appear before trial. But for people who are detained, we don't get to see what would have happened had they been released. And so because we only selectively observe this y star, we're not going to be able to directly compute this measure. And so the first contribution of this paper is to show how we can overcome that challenge using quasi-random judge assignment. And I'll say more about how we actually do that in just a second. But that's going to be the first half of this paper, is thinking about how to solve this selection challenge. Now, this is going to be a model-free approach in the sense that we're not going to put any restrictions on sort of the judge behavior or beliefs, except for their sort of interest in this yi star. And what that means is that this measure of what I'll call discrimination is going to be a fairly broad measure, because it's not going to rely on any sort of model assumptions. Now, just to drill down on that a little bit and say what this does and doesn't capture, I said this already in words, but what a delta J that's positive means is that white defendants are released before trial at a higher rate than black defendants with identical misconduct. Now, this is a broad notion of discrimination that we think is in the spirit of Aigner and Kane, who were studying labor market discrimination. They were thinking about the labor market treatment of workers with the same level of sort of inherent productivity, that latent variable productivity. We're going to think about the analog of productivity in this setting as an individual's potential for pretrial misconduct. But that's the sort of, I think, theoretical motivation for caring about this as a measure of discrimination. Now, it's a broad measure of discrimination in the sense that it's going to capture both sort of racial bias and statistical discrimination. And just to say a little bit to make sure we're on the same page about what those two things are sort of formally. So what I'm going to call racial bias is something in the tradition of sort of Gary Becker, which is, true sort of racial animus. So the judges, treating white defendants differently than Black defendants because of either some true animus or because of some sort of stereotypes or biased beliefs. Now that's the kind of bias that might be picked up in, if you're familiar with this literature, what's called a sort of standard outcome-based test. But what our measure is also going to pick up is statistical discrimination, where the judge is sort of accurately predicting misconduct potential from some observables and acting on that accurate prediction in a race-neutral way. And there's a theoretical literature talking about how, that form of discrimination can also lead to these kinds of conditional disparities in treatment. One thing that's, I think, worth highlighting here is that, we're going to pick up by this measure any unwarranted disparities in treatment that arise even from seemingly race-neutral practices if they have a disparate impact on one group. So in the US, this example is salient. I'm not sure how salient it is to everybody in this audience, but there's a notion of redlining in mortgage lending, where individuals from majority Black neighborhoods are maybe less likely to receive a loan than individuals from majority white neighborhoods. That's an example of a practice that doesn't target people directly by race. It targets them based on neighborhood, the neighborhood that they're from. But it can lead to this kind of discrimination if judges are sort of placing disproportionate weight on neighborhood relative to an individual's sort of qualification for a loan. We make an argument in the paper that there's reason to think that this measure of discrimination might be illegal or at least suspect in this context, but let's not dwell on that today, because I don't think that's necessarily the right way to think about our agenda here. And so all I want to say by this is that this measure, this delta J measure, is very broad. It captures lots of different types of things that we might call racial discrimination. I think that's good on one hand. It's kind of a model-free approach. It captures a lot of things that we think are important, but it's also a disadvantage because we want to understand sort of what the drivers are of this object. And so for the second part of this paper, which I'll probably talk less about today in the interest of time, we're going to sort of put more structure on the problem, make more sort of a model-based approach to disentangle these drivers and learn about racial bias on one hand and statistical discrimination on the other. Now, let me just quickly say that this agenda has a lot of connections to the literature, both theoretical and empirical, and also, of course, some methodological connections. In the interest of time, I won't dwell on any of these connections today, and instead just pause there before talking about the data and see if there's any other questions about where we're going.
Can I ask you a silly question? Maybe it's not a silly question, but so if you could randomize the set of information, so say take two judges, or they are equivalent, and except for the set of information they have, if you could randomize that set of information, would that solve your identification problem?
I don't think so. No. So so this is actually a very good question, but it leads me to a very subtle answer. So let me give that answer, and if it's not clear, we can talk more about it afterwards, maybe. But so I think a lot of people's benchmark in this setting is to think about audit studies, where I randomize, say, the race of an individual. That's part of the judge's information set. I'm not sure if this is what you're asking, but let me and yeah. So in that setting, say we could do that here. We can't actually do that here because it's a face-to-face interaction. It's very high stakes. No IRB in the world would let us randomize race here. If we did that, the parameter that we would get is actually, in principle, different from the object that I'm going to be estimating. And to see why that is, we can think again about this redlining example. If judges were, redlining in the sense of penalizing people who come from majority Black neighborhoods, but not targeting race directly, so that's a seemingly race-neutral practice that has discrimination by this measure, then an audit study wouldn't pick that up. Because an audit study would say that white and Black individuals if they come from the same neighborhood, the judge doesn't make a distinction between them. But our measure would pick that up. And so that's one example of how those two approaches are going to differ. I'm going to argue that a measure that includes discrimination on race-neutral practices is sort of as interesting, if not maybe more interesting in this setting. But that's my sort of subtle answer to your actually very, very quite insightful question. Hopefully it's helpful. Any other questions on where we're going? Okay, great. I think I need to speed up given that it's half an hour already. Okay, so let me talk about the setting and the data more concretely, and then talk about the methods that we actually develop here. So we're going to be studying New York City bail decisions from 2008 to 2013. The key variables for us are race. So as our baseline, we're just going to split people up into white individuals and Black individuals, grouping together other forms of race and ethnicity, such as Hispanic status. And we do some stuff to check robustness there as well. The main treatment variable for us is going to be an indicator for pretrial release. So that is any release type. The vast majority of that will be release on recognizant without any conditions. About 73% of people are released before trial. The main outcome for us is going to be pretrial misconduct. That's going to be an indicator for either a failure to appear or some form of rearrest. So engagement in further crime prior to their trial. Conditional on release, about 30% of individuals engage in pretrial misconduct. But of course, we don't see pretrial misconduct for people who are detained. That's the selection problem we're gonna grapple with. We see a lot of case characteristics here. This is the universe of arraignments with all the sort of defendant and case observables. But there is also important information that we don't see. So, you know, these individuals are interviewed by the judge. There's a lot of soft information that comes up. And of course, we don't know sort of necessarily the right way to use this information. And so there's a lot of potential for omitted variables bias here. One thing I'm not going to spend a lot of time on today, but hopefully is familiar to many people in this audience, is the source of quasi-experimental or quasi-random variation in this setting. So this is something that has been used a lot in settings like this and in New York City specifically. And that is a sort of rotational assignment of judges to cases, which generates some randomness in which judge you get to see when you're brought before trial. And so we're going to use that variation. I won't talk about where that variation comes from in a sort of institutional way, but we do check for balance, and I'm happy to again talk about all of that after the talk. So here's some basic summary statistics for the sample. 73% of individuals are released before trial. I said there was about a 7 percentage point gap between white defendants and Black defendants. You can see that in columns 2 and 3. The vast majority of release, as I said, is released on recognizance. That's without any conditions. Some people are released by paying some bail, but it's a small fraction, and it's very similar for white and Black individuals. So that's the reason why I'm not going to emphasize the bail amount in this main analysis, though in the paper we talk about, you know, how we can think about that complication. So Black defendants tend to be detained or before trial or not released before trial at a higher rate, and you might think that's because, you know, Black defendants tend to be riskier. At least that might be an explanation for why that could be. Indeed, we see that Black defendants tend to have higher rates of past pretrial misconduct, so higher past rearrest or FTA rates. And we also see that, you know, among the people who are released, Black defendants have a higher rate of pretrial misconduct. Now, that doesn't, you know, fully answer our question here, because again, we don't see the misconduct probability of people who are detained. And so we can't use these numbers to really understand how much of that 7 percentage point difference is fully explained by differences in misconduct potential. But it is suggestive that there is sort of this omitted variables bias problem here. Here is one of my favorite motivating pictures from the paper, just to show you, you know, that there is a lot of racial disparity in release rates here, not only on average, but also across judges. So what I'm plotting here is the distribution of judge-specific release rate disparities by race, white versus Black. So the blue curve here is without any further controls. This dashed line corresponds to the average disparity of about 7 percentage points. But you can also see that there's a lot of variation across judges, and that most judges have some racial disparity favoring white defendants. So 96% of judges in the sample have a higher release rate for white defendants than for Black defendants. The orange line shows that that remains true even with a bunch of controls, case characteristics, defendant characteristics. Those do shrink the average disparity again from about 7 percentage points to 5 percentage points. But it remains true that there's a large majority of judges who have sort of a positive disparity favoring white defendants. It's also true that there's a lot of variation across judges. So some judges have a very high release rate disparity, and some it's much closer to 0. So we're going to think about, how much of this variation is due to just differences in risk, how much of it is due to racial discrimination, and then later racial bias and statistical discrimination. But that's sort of where we're going next. So let me pause again here if there's any questions on the data or the setting. Great. Okay, so let's now talk about how we tackle that sort of key measurement challenge here. So just to recap, right, our goal is to estimate this delta J parameter for each judge. So for each judge, we want to know, conditional on true misconduct potential, what the treatment differential is for white individuals versus Black individuals. What do we get to see? We get to see a defendant's race. We get to see what judge they're assigned to. So I'm going to write ZIJ as an indicator for individual I being assigned to Judge J. We see the release decision, DI. So that's just the potential release decision of the judge you're assigned to. That's what this expression is writing in potential outcome notation. And we also see sort of the actual pretrial misconduct of each individual. Now, for individuals who are released, so when DI equals 1, that's their misconduct potential. But whenever an individual is detained, so DI equals 0, the outcome is censored. We don't see their misconduct potential. Anyone who's detained cannot engage in pretrial misconduct by definition. So that's what this expression is writing here. Now, this is, again, sort of the key challenge for us is that, we only observe this censored outcome, if you will. And so we can't condition on yi star directly in this expression. What we can do is what I was showing you in that previous figure, which is compute just the observed racial disparities in treatment across judges. So if I focus on a given Judge J, I look at the defendants assigned to that judge. I look at the release rates of white defendants, and I subtract off the release rates of Black defendants. Then I get, by random assignment, if judges are randomly assigned, which again, I haven't talked much about, but let's just assume that judges are randomly assigned. And what I get is the difference in potential release rates for white defendants and Black defendants for that judge. And the point is that this parameter alpha J, which I was showing you in the previous picture, is different from delta J because we aren't conditioning on yi star here, whereas we are here. Now, when are those two things going to be different? When is alpha J going to be different from delta J? That's going to be what I call omitted variables bias, when these parameters don't coincide. You can show that you generally have OVB whenever race and yi star are correlated. So this is sort of usual OVB logic. If you're familiar, you can think of what we're doing here as basically regressing release on race. And what we want to be doing is controlling for yi star. And so whenever we, have this long regression in mind where we control for yi star, but instead we run the short regression where we don't control for yi star, then we're going to have omitted variables bias when yi star is correlated with the included variable race. So that's sort of the intuition for when this problem is going to arise. And what's nice here is that you can show that that's just a function, that form of correlation, that reason for OVB is just a function of two numbers. It's just a function of the average misconduct risk or the average yi star by race. And so what this tells us is that, the extent to which we sort of have this problem from not being able to observe yi star directly is going to come about whenever the average risk for white defendants is different from the average risk of Black defendants.
Can I ask?
Yep.
Sorry.
Please. No, please go ahead.
So in the alpha J definition, so I don't understand why you're not conditioning on anything except for the race and the Z. I mean, you're certainly conditioning on some Y. I understand it's not Y star, but they do get to observe something and they make a decision on that, right?
Absolutely.
And it's exactly the difference between that Y and the Y stars, which gives you this difference between alpha J and delta J, I think.
So I'm focusing on alpha J because of where we're going next, which is to show sort of how we can solve this problem by, and I didn't say this, by sort of bias correcting this alpha J, which doesn't control for anything. You could replicate the argument I'm giving you for an alpha J that adds X's to the controlling, and so there is a version of this that considers the conditional disparities. The solution I'm going to propose doesn't use covariates, actually. And there's a question of whether you want to use covariates or not. And this actually gets back to our earlier back and forth about the redlining. It's not clear necessarily that you want to control for things. It might bring you closer to delta J. It might not if those things are a form of the discrimination, like neighborhood, for example. But suffice to say, where we're going is to solve OVB in this alpha J, but you could think about solving it in a conditional version.
Okay, thanks.
Did you think about classifying or grouping the judges to reduce their idiosyncratic risk, for example, by race?
That's interesting. So we don't see judge race, unfortunately, in this data. We don't actually see a lot of characteristics of judges, which is going to limit, I think, our ability to do what you're suggesting.
You could do a k-means cluster based on their decision making, though.
You could, yeah. So I'm not so worried about like estimation error here. Right now, I'm just thinking about sort of the population problem and thinking that I have effectively an infinite sample for each judge. In practice, and in New York, actually, we do have a lot of observations per judge. That's something I didn't say before, but because it's so big, I'm not so worried about estimation error. In practice, you know, if you were, you could do that, but I don't think that's going to help necessarily solve the OVB challenge that I'm going to be tackling here as an identification matter. Maybe I misunderstood the question, but that would be my suspicion.
And another quick question, what's the average time between pre-trial and trial, and what's the recidivism rate between pre-trial and trial?
That's a good question. So on the second question, that should be in this table, actually. So a failure to appear rate is about 27%, between about 27 to 30% of people fail to reappear before trial, conditional on release. In terms of the length of time, I should know that, and I don't offhand. I'll have to go back to my co-authors on that.
So if somebody doesn't have the money to pay to get out of jail, how long are they in jail for before they get to trial?
Good question. I'm sure there's a lot of variation, but I think there's also an average, which we should report, and I just don't know it offhand in this setting.
Thank you.
But shoot me an email and I can get back to you on that if you're interested.
Sure. Yep. Thank you.
Yep. Okay, so let me just sort of walk through the bias problem, and this will also set us up for our solution here. And so to do this, I'm going to consider a very simple setting where we just have two races, a high-risk race and a low-risk race. So abstracting away from white and black, let's just consider high-risk people H and low-risk people L. And let's consider them high-risk by their difference in average misconduct potential, mu. So high-risk has a higher mu than low-risk. And let's suppose that we have a judge who doesn't see race, but is somewhat able to predict pretrial misconduct potential. So I'm going to call this a race-neutral judge. I'm going to assume that this judge is able to, release about 80% of people who have no pretrial misconduct potential, and only 20% of people who have misconduct potential. So the judge isn't perfect; they make mistakes. This number isn't 100% and 0%, but they're pretty good at predicting and treating people accordingly to their true Y star. Here's what we get in this very simple example in terms of the release rates by race for this judge. So in column 1, I'm just summarizing the distribution of people by race and by pretrial misconduct potential. So the low risk race has more people with y star equals 0. The high risk race has more people with y star equals 1. In column 2, I'm applying the race neutral rule to this distribution. So I'm just assuming that the judge releases 80% of the people without misconduct potential and 20% of the people with. Then we get these numbers here. And then in columns 3 and 4, I'm using these to just compute the race specific release rates and the disparity. And what's the point of this table? The point is just that even in the setting where the judge doesn't see race, they're just sort of applying this race neutral rule to misconduct potential. We do see that L defendants tend to be released at a higher rate, and that's simply because those defendants are lower risk, right? So pretty simple point, but just to make things very concrete in terms of showing how we're going to solve this next. And here's how we solve this. What we show in the paper, and what I won't work through the gory details of now, but hopefully build some intuition for, is that when judges are randomly assigned, we can identify this delta J by rescaling or reweighting the data that we previously used to get that unconditional release rate comparison. So before I was showing you that alpha J is this average D by race. Now I've introduced this parameter omega I, which varies across individuals. It's what we're going to call a rescaling factor. It's this, if you want a formula for it. But what it is it's basically rebalancing the sample to make white and black defendants who are released comparable in terms of their misconduct potential y star. So well, I'll show you what it actually does in the example in the next slide. But what I want to make the point of here is that it's a function of the actual misconduct outcome of each individual. That's y. So that's something we observe in the data. And it's just a function of these average risk parameters, mu r and mu bar, which is the average across races, the overall average of risk. And so what it is doing is it's effectively, upweighting and downweighting individuals according to how their risks, the race-specific misconduct risk relates to the average in the population. And in doing so, what it's doing is effectively solving the OVB challenge. It's solving, the fact that individuals have different misconduct risk on average by appropriately reweighting the sample. Now that might sound like magic, so let me show you how this bears out in our example. So here's again the numerical example: low risk, high risk individuals. Here's again the number of people who are released by that race neutral judge. What I'm showing in column 2 is this rescaling factor with the formula I showed you on the previous slide. And what this rescaling factor is doing, you can see here, is it's upweighting the individuals who are more rare in each race. So why do I say upweighting? I mean that this rescaling factor is greater than 1 for the low risk individuals who have misconduct potential. And it's greater than 1 for the high risk individuals who don't have misconduct potential. Correspondingly, it's less than 1 for the individuals who are more common in each race. So it's downweighting those individuals. And what you can see from this example, if we multiply columns 1 and column 2, then we get this rescaled release rate in column 3, where there is no racial disparity. So the rescaled release rate of both races is 0.5, the racial disparity is 0, and that's consistent with the fact that the judge is race neutral here. The judge is not actually targeting race at all. Now, what I argue is that this is a very generic phenomenon, such that if you can compute this omega I, if you know omega I and you use omega I to rescale the unconditional release rate disparities from before, then that's going to solve this omitted variables bias coming from the differences in misconduct risk. And that's useful because this omega I is a function of things we observe, y, and it's also a function of things which I'll argue we can estimate in just a second, mu. And that's the average misconduct risk of white and black individuals. I'm going to speed up here because I do see I only have 15 minutes, and thank you, Paul, for holding questions. I hope that's clear, and very happy to talk more about that afterwards if there's interest. But let me just sort of give the summary, the sort of high level takeaway from this part of the presentation. We can solve the OVB challenge. We can measure this delta J parameter for each judge under 3 assumptions. One is that judges are randomly assigned. And again, that's not something that I've given much support for, but is in the paper and is hopefully familiar to some of you. One is that the legal objective of judges here pretrial misconduct, is known and well measured among released defendants. So that's something that we can argue about, whether that's the right sort of outcome. We could potentially take different definitions of that. But that's sort of the second key assumption that we need here to interpret this procedure as estimating racial discrimination. And then the third key assumption, which I haven't talked about at all, is how we get the missing parts of that omega I rescaling factor, which is the average misconduct risk for white and Black individuals. So we need to be able to estimate those things, and that's where we're going next before bringing things to data. But the point is that we've simplified the problem immensely. The problem started as, well, we don't see misconduct potential for everybody. And what we've found is that we don't need to measure misconduct potential for everybody. We just need to measure two numbers: the average risk of white individuals and Black individuals, and then appropriately rescale the data. So that's where we're going next. Okay, so this is just what I was saying before. To estimate discrimination, we need to estimate these mean risk parameters, these mu R's. To build some intuition for how we're going to do this, I want you to imagine that we have a judge who releases everybody that is assigned to them. So we're going to call this a supremely lenient bail judge. Now, in practice, as we've seen, only 70–80% of individuals are released on average. But let's imagine for a second that there's some judge who's just very, very generous and releases everybody no matter what. Because of random assignment, we can use that judge to directly estimate this misconduct rate mu R. Effectively, there's no selection problem for this judge, right? So normally we only see misconduct rates among the people that a judge releases, but this judge releases everybody. And because by random assignment, the individuals that this judge releases are just some random draw from the population, we can use the misconduct rates of the released individuals for this supremely lenient judge to estimate the missing parts of that rescaling formula. Now, in practice, we don't have this judge. There isn't, for better or worse, probably for better, there isn't a judge who just releases everybody before trial. So what we're going to do is we're going to use the observed variation in release rates and misconduct rates across judges to extrapolate out and estimate what the misconduct rate would be if we had a judge who released everybody. There's a lot of ways that you can think about this approach. One that might be helpful for people who are familiar with the regression discontinuity is that that's basically what we're doing here. We're going to be using the variation in release rates and misconduct rates across judges to try and extrapolate potential outcomes and estimate the mean risk if we observed a judge who released everybody. This extrapolation could be model-based, it could be non-parametric. I'll show you an example of that in just a second. More formally, if you're familiar with identification at infinity, you can think of that's basically what we're doing. But let me show you sort of in pictures what we're doing, because I think that'll make things a little bit clearer. So what I just argued, and what I hope is not too hard to follow in the short amount of time I argued it, is that if we had a judge who had a release rate of 1, so this judge released everybody, then if we plot release rates of judges against misconduct rates among the people that a judge releases, that judge who releases everybody, that supremely lenient judge, would tell us the average misconduct rate in the population. Again, that judge sees just a random draw of people and then releases them. And so we get to see the average sort of mu from that judge. Now, we don't see that judge, but we do see a lot of judges with sort of relatively high release rates. And we also see variation in release rates across judges. And so what do we do when we normally see a cloud of points like this? Well, we draw a line through it. And what I'm going to argue is that, if we see judges and we see this sort of upward sloping relationship, we can extrapolate out from the variation we observe to the variation that the point that we sort of want to estimate, and use this as our estimate of mean risk. And then we can use that to reweight the data and solve the OBB challenge. Now, in practice, we're going to do this by race. So we're going to do the same thing for white individuals and Black individuals. And we're basically going to use the intercept of these lines at 1 as our estimates of mu. And then we're going to plug that in to reweight the data and estimate discrimination. Here's what the data actually looks like. So what I was showing you was just a very simple example to build intuition. But here in New York, what I'm showing you now is for each judge and each race, the release rate on the x-axis and the corresponding misconduct rate among the people that judge releases. What you can see is we still have this sort of upward sloping relationship, and we have a roughly linear relationship between release rates and misconduct rates. So I'm plotting a line of best fit through these points, as well as a quadratic and a local linear fit. And the basic point is that, for each of these different extrapolations of the data, we get a different estimate of mean risk by the intercept at 1. And, they're fairly similar. There is some differences there. What we can then do is take each of these numbers and plug them through that reweighting formula I showed you before, and obtain different estimates of discrimination for each judge. Here's what we get when we do that in the data. So in each column here, I'm showing a different mean risk estimate, a different estimate of mu R for white individuals and Black individuals, using a different extrapolation of those data. So we get a pretty robust finding here that Black defendants are of higher risk on average than white defendants. It's fairly similar. It's a little bit bigger for local linear than for quadratic. It's about in the middle for a linear extrapolation, but it's fairly consistent, at least in showing that Black defendants tend to be of higher risk, which implies that there is indeed some form of omitted variables bias for us to solve. So what we're next going to do is take these mu R's, plug them into our calculation for omega I, and estimate the average discrimination across judges implied by these numbers. That's what we get here. So what this is saying is that the average delta J, or the average discrimination across judges, is about 4 percentage points in our most conservative sort of local linear extrapolation, but it's about 4 to 5 percentage points across these different columns. If you recall, the average release rate is about 7 percentage points in these data. So what this says is that about 60 to 66%, 2/3 of the observed release rate disparity cannot be explained by differences in misconduct risk. And so that's what we say is discrimination in this sense. If judges were just acting on differences in misconduct potential, then this number would be 0. And it's instead a quite large number relative to the overall. So there is omitted variables bias, but it is a relatively small share of the observed disparity. And what we can then do is sort of run with this number in a number of ways. So we can explore heterogeneity across different individuals. So this is breaking people out by the crime type that they're brought in on. You can see that sort of across different types of crimes, we do get discrimination. It varies in magnitude and in some settings is very imprecise. But it's not just this driven by one particular form of crime. It seems to be a fairly robust finding across different types of defendants. The other thing that I think is kind of interesting is we could do this across judges. So to return to that figure that I liked before, I like this figure even better because now in the orange curve, what we're doing is we're not adjusting for observables, we're adjusting for this Y star. So this is the distribution of implied delta J's across different judges. We still see a very large average unwarranted disparity here, again, of 4 percentage points. But what's interesting is that we also see, a lot of variation across judges. So some judges are more discriminatory than others. The vast majority, again, are still discriminatory in the sense of not this number not being 0. But there is some interesting variation, which we can also explore. So we can project, our discrimination estimates for individual judges on a number of judge characteristics. What we see from this table is that newer judges tend to be less discriminatory. Judges who are more lenient, so people who release more defendants overall, tend to be less discriminatory. What I think is kind of most interesting is that judges who are exposed to more Black individuals, sort of before adjusting for the strata that we need to isolate quasi-experimental variation, those judges tend to be less discriminatory. And there's also some interesting geographic variation here as well. So judges who work in Manhattan tend to be more discriminatory than judges who work in the Bronx, for example. So these are the kinds of things that we can now do to understand, this heterogeneity once we've bias corrected using our method. Now, as I was mentioning before, there are a lot of things that we wish we could observe about judges, but we don't. So we don't observe judge race. I think that would be really interesting to look at here. We don't observe judge gender or age directly. So I think there's still a lot of very interesting things here to be done in terms of understanding what's driving this variation. One thing that I think is kind of constructive here is we can look at a judge's discrimination over time. So here we're splitting the sample into sort of first set of years and the second set of years and computing each judge's discrimination in both halves and then correlating with them with each other. And what we find is that, it's a fairly reliable predictor over time of a judge's discrimination posterior in one given period. So that tells us that to the extent that we think that this, is undesirable and want to sort of target these delta J's, there is some scope for doing that because judges seem to have persistent behavior over time. I won't talk about all the various robustness checks we do for this, but I'm very happy to if people are interested. But suffice to say, we kick the tires on these estimates in a lot of ways. It seems a very robust finding that judges are discriminatory on average, and that there's a lot of variation in that across different judges. Happy to talk about any of these as well. Now, I only have 3 minutes left, and that is unfortunately only the first half of this paper. I anticipated that this would be hard to do in an hour. It's usually hard to do in an hour and a half as well. So I hope you'll forgive me for not spending time on sort of what I think is the next question here, which is once we've found this discrimination using our quasi-experimental approach, how do we understand whether it's coming from racial bias or statistical discrimination? Let me give a very high level overview of how we do that. How we do that is by specifying a very simple decision model for judges, in which judges are sort of acting on signals, noisy signals of pretrial misconduct potential, forming posterior beliefs, and releasing defendants with low posterior risk. There's a lot of interesting econometrics here in estimating this model, which I'm going to skip. But the point is that this model allows us to sort of characterize both racial bias in the sense of animus or inaccurate beliefs, as well as statistical discrimination, in which a judge is sort of acting on some accurate posterior of misconduct potential, using race-neutral thresholds to decide who gets released, sort of doing everything that we as economists might expect judges to do if they were sort of race neutral, and how that might still generate discrimination in the setting for the usual reasons in statistical discrimination. Let me skip over the details here. Sorry, this is quite a bit, but let me just summarize that what we find by fitting this model is evidence of both racial bias and statistical discrimination. So judges seem to set higher thresholds for white defendants than Black defendants in terms of the posterior risk for these individuals. So they seem to be willing to release individuals that they think are riskier if they're white than if they're Black. On the other hand, we do find scope for statistical discrimination as well. So that comes from the fact that white individuals are of lower risk than Black defendants, and also that it seems that Black defendants tend to receive noisier signals of their misconduct potential. And so even if judges weren't biased, even if they set the same sort of tolerance or risk tolerance for individuals, these two things combined would create discrimination in the setting. So it's neither one thing or the other. It's a combination of both of these factors that contributes to the discrimination that we find. Lastly, what we can do is you can use this model once we fit it to understand a variety of counterfactuals. So we can think about, well, what would happen if we forced judges to release more Black individuals or fewer white individuals in order to try and mitigate this discrimination if we thought that were both sort of desirable and feasible. And suffice to say, what we find for this is that those sorts of policies could be very effective. So if judges are targeted based on posteriors of their sort of delta J's, then the data are rich enough that we can actually eliminate discrimination in that sense from targeting those posteriors. Okay, so I'm out of time. So let me just wrap up there and open the door for future conversations about these things if anyone is interested. So what is the point of this paper? It is, I think, primarily a methodological paper in the sense that we are developing and promoting new quasi-experimental methods to measure a notion of discrimination. And we do this in 2 steps. We first use quasi-random assignment to judges to estimate the average misconduct risk of white individuals and Black individuals. And then we use those estimates to reweight or rescale the data to solve the omitted variables challenge from not observing misconduct potential directly. And then there's a second part of the paper, which I basically skipped over, where we use a model to try and understand the drivers of that discrimination. In New York City, we find that there is significant racial discrimination. 2/3 of the overall release rate disparity seems to be due to discrimination in the sense of not being explained by differences in the misconduct risk. And that seems to come from both racial bias and statistical discrimination. And we have some policy simulations suggesting that these problems can be addressed if it's desired and sort of feasible. Let me just close by saying that we hope that these methods are useful very broadly. So we developed them in Bail because Bail has some interesting institutional features that are sort of very well developed for this approach, but we think that those features could be found in many other places, both inside and outside of criminal justice. So the key requirement is that we have some form of quasi-exogenous or exogenous assignment of decision makers, so judges in this setting. We need these judges to have some narrow and measurable, at least partially measurable objectives, so pretrial misconduct potential in this setting, and that they make some sort of treatment decision that's endogenous, that endogenously censors that outcome for different individuals. So I've talked about this in Bail, but we could think about other settings, such as police officers making decisions about who to pull over in traffic decisions. We can think about benefit examiners for public programs deciding who's eligible or who's not, doctors making treatment decisions, employers making hiring decisions. Those sorts of settings I think are very interesting for using these methods. So let me stop there. Thanks very much for holding questions for the last 15 minutes. I'm very happy to engage and answer them. Thank you.
Thank you very much, Peter. That was wonderful. We have a few questions in the chat. I think Sergey had one or two.
Yeah, Sergey, do you want to unmute and ask, or should I just read the question?
It's just general. I'm just trying to format. Can you hear me? Am I here?
Yes.
Yeah, I can hear you.
Yeah, I'm just trying to connect. Because I like the method. The leniency design is something I aspire to do myself, and I'm just trying to connect the dots here. And if you remember in Dobby 2018, the way to calculate the complier share, they were trying to see whether the bail decision actually going to change if we hypothetically reassign a person, a defendant from the least lenient to the most lenient. And so there was a lot of extrapolation of judge's decision. And my impression is that your sort of work is essentially just a kind of the same thing, but on just a continuation of this idea. Then when you can play with the, is that a correct impression or?
Yes. Yeah. No, that's a good connection to make. Yeah. So in the plot I was showing you before, with the variation in judge release rates, you can think of those as capturing variation in compliance rates. So if you think about, as you move along that x-axis, you get judges who are sort of more lenient. Those judges have a higher complier share than judges who are lower down. Now, one thing that I didn't mention at all, but is actually kind of a cool methodological feature of this work, is that, unlike in a usual IV analysis of this setting, where you assume monotonicity, which allows you to think about compliers, always takers, and never takers, we're not actually going to use monotonicity in this setup at all. That's something I would talk about with more time, and happy to follow up if you're interested. It's kind of a nice feature here because there's a lot of concern about that assumption in these settings, right? Because what allows us to talk about compliers and always takers and never takers is this assumption that judges can be sort of ranked by their leniency by differences in complier shares, and so we are actually relaxing. But
I guess I have a follow-up. So it would be interesting, just a suggestion, because it would be interesting, I guess, because so you focus on race, but it would be interesting to, as a falsification test, to see whether you can, instead of race, do something which cannot possibly be discriminated, something ridiculous, whether or they or something. And
that's
see
a great idea.
If your method still can show discrimination, because that would suggest to me that something is fishy.
Yeah, that's a really good idea. We haven't thought about that. Yeah, we could use something like weather or day of week, or like
something
number letters in someone's last name or something. Yeah, that's a great idea. We'll think about that. Thank you.
Thank you very much. It was excellent presentation. Thank you.
Thanks so much. I think there's also a question from Simon. I can just read this off. So Simon is asking about whether we know judge name. Unfortunately, we don't actually. So the data are anonymized for us, and I can say, that it might be an uphill battle for us to get that information. It is disappointing because I think we really want to understand what this heterogeneity across judges is now. And there's a lot of candidates like demographics that we just won't be able to get at, I'm afraid.
Fair enough. Thanks.
Yeah.
All right, are there any other questions?
I wanted to ask something that's just like minor, but the relationship between the leniency and the bias, it seems like that might be a mechanical one. If if you have 50% leniency, you have a big scope for discrimination, and if you have 100% leniency, there's no scope for discrimination.
Yeah,
So
I think that's right. Yes, you're talking about this number.
yeah,
Yeah, I think that's right, that if you're closer to 1, there's sort of mechanically less possibility for, I mean, it's not necessarily true. You could widen that disparity, but as it gets to 1, you get this sort of upper bound at 1, I guess is the point. Yeah.
yeah.
I think that's right. I don't want to overinterpret these because they are correlations. The typical range, as you saw, of leniency is not super close to 1, so it's not it's not like we're really comparing 0.99 and stuff. But I think you're right that this could be partly what's going on here.
Peter, sorry, this is possibly a silly question. You use the term racial bias here. Am I to interpret that term as the old taste-based discrimination or something more than that?
No, that's a great question. So yeah, when I say racial bias, what I mean is both sort of taste-based discrimination in the sense of Gary Becker, but also things like stereotypes or biased beliefs. So those will generally manifest, very similarly, sort of observationally similarly in these sorts of settings. And in general, it's hard to disentangle a judge who is, has racial preferences versus just sort of misguided beliefs that white defendants are more risky or less risky than Black defendants. Right. But that is exactly the type of thing I want you to think about with racial bias. In particular, I want you to think about it as separate from statistical discrimination, where beliefs are correct and there's no racial animus. Right. I think that's the.
Okay, well, everybody, let me thank you, Peter, for kicking off our sort of webinar series. Yes, I think we can all agree it has been a pretty exciting presentation and amazing work. And as I said, I mean, we hope we can, it would be nice to have our webinar presenters sometime in the future in person down here. The next webinar is in 2 weeks, March 16th. It's from 5 p.m. to 6 p.m. And our presenter will be Tianji Wang from University of Copenhagen. And we will have another paper on racial discrimination. It's about Black radio and the civil rights movement in the US. And I hope I see many of you there as well. Thank you very much, Peter.
Thank you very much. It was a lot of fun.
Thank you, Peter.
Bye, everyone.
Bye.